Often when you migrate data into the cloud, there are three things that you really need: CPU, I/O, and network. One of the good things about being in the cloud is that you can scale on demand. For VMDB systems, you can't really scale the number of CPUs on your existing system, but you can change the shape. So you can go, for instance, from a 2 CPU shape to a 24 CPU shape, and you can scale up and down. But it requires downtime, and it typically takes 10 to 15 minutes to change the shape of a VM. When it comes to I/O, the speed of your disk subsystem is depending on the amount of total storage you have. So the more terabyte storage you order, the faster the I/O subsystem will become. The only thing you have to be aware of is that storage on VMDB systems scales up, but it doesn't scale down. So it doesn't make sense to add a lot of storage to handle a migration because you can't get rid of all that storage afterwards. The network throughput scales with the number of OCPUs, and we can see that on the next slide. On the left side, you can see the correlation between the number of OCPUs on your VM and the network throughput that you can get. And you can see if you scale all the way up to 24 OCPUs, you can get a maximum throughput of 3,200 megabytes a second, theoretically. So that equals a 25 gigabit network. On the right-hand side, you can see the correlation between the total amount of storage and the capabilities of the I/O subsystem. So in order to match the speed of the network, you have to provision at least 20 terabyte of storage. When it comes to bare metal, these are a little different. You can scale the number of CPUs, you can scale it up and down, and it happens really fast and it happens online. The disk subsystem is locally attached NVMe disks, which are really fast and they cannot be scaled. The same goes with the network. The bare metal system has a 25 gigabit network speed, and that can theoretically reach up to 3,200 megabytes a second. And that should give you around 11 terabytes of network throughput an hour. With the Exadata, it's virtually the same as the bare metal. You can scale OCPUs up and down, and with Exadata, you can go from 2 to 400 OCPUs, depending on which type of Exadata you have. The OCPUs, they scale online and they scale rather fast. The disk subsystem cannot be scaled. You have access to the Exadata storage, and you cannot make any changes to it. But it's really fast, and typically you have a lot of storage provisioned. The external network of the Exadata is also a 25 gigabit network. When you need to transfer data into the cloud, you should really use multi-part uploads, and you should at least do it for files that are larger than 100 megabytes. You can use the OCI CLI tool to transfer the files. You specify the chunk size. In my example, I've decided to split the file into chunks of 1024 megabytes, and I'll do 4 concurrent uploads at the same time. In addition to that, if you have many files to upload, you should use bulk uploads. This also does multi-part uploads under the hood, but instead of specifying one single file, you specify a source directory, and all the files in that directory is transferred to the cloud. It does 10 concurrent uploads by default, but it's configurable. Also, the chunk size is configurable. And there's also the option of specifying a prefix. So all the files, when they are transferred to the object store, will be prefixed with a text that you can specify. What I also would recommend you is to checksum your files when they are uploaded to OCI. Often, when the file has to transfer from your location to the cloud, something can go wrong in flight. We do see from time to time that, for instance, data pump dump files get corruption in flight. But you can most likely verify that using MD5 checksums. In Linux, you can use the MD5 sum command to generate a checksum of the files, and you can compare that checksum to the checksum that you can get from the DBMS cloud package, which calculates the checksum on the files when they are in the object store. If the checksum is the same, there is much less chance of corruption in the actual files.